Good day guys, welcome to another tutorial on PHS 105. My name is Olasende Fit, and in this tutorial we are going to be covering projectile motion. In the previous tutorial we covered motion on basically vertical motion and horizontal motion. That's vertical motion are the ones that goes vertically, like upwards, and horizontal motion forward or backward. Well, in this one, projectile motion would carry both the vertical and horizontal, therefore it results into another kind of motion, a resultant motion that goes both vertically upward and horizontally forward. So let's take this one as our vertical component, which is uy, that is, it goes along the y-axis, and this is the horizontal, it goes along the x-axis. So that means this one will be the resultant, which is u on its own, and it definitely has an angle with which it is being projected, like that. Then from this point to this base is the height. Okay, now having said this, from what we have here, we can bring out the first set of formulas in projectile motion. Then that means if we have a resultant motion, we can tell the vertical component of the motion, we can tell the horizontal component of the motion, since it is already forming a triangle, a right angle triangle. So you take this place as the uy, this is the ux, and this will be the resultant, which is just u. So that means if you know u for a projectile motion, if you know the velocity of a projectile motion, you can tell its horizontal component, the velocity forward or backward, and you can tell the velocity at which it moves upward. So in order to get this, let's use the function, trig function. Let's start with sine theta. Remember, sine is opposite over adjacent, and opposite here according to this is uy over, I said adjacent, sorry, hypotenuse. Hypotenuse here is u. So that means sine theta, according to what we have in this projectile motion, is uy all over u. So we can then say uy equals to u sine theta. So that means if this projectile, if this object that is going in a projectile motion goes with a velocity of u, and you want to know the velocity with which it goes upward, then you use uy equals to u sine theta. And if you want to know the velocity with which it goes forward, then that should be cos. Let's try cos. Cosine is all adjacent all over hypotenuse, and adjacent here is ux, hypotenuse is u. So cos theta equals to ux all over u, then ux equals to u cos theta. So these are the first set of formulas that we need to understand for projectile motion, because some questions might require you to know the vertical component of a motion, and some might require you to know the horizontal component. So this is the formula you use to get the vertical and the horizontal component. So this motion comes in different form. This projectile motion comes in different form. There are some, like this one now starts from a point and it lands on the same point. There are some that starts from a point higher, then lands on a point lower, or maybe the other way around, starts from a point lower, lands on a point higher. Anyhow it goes, and all these things, their parameters differ. But we are going to cover all those in a question. I wouldn't waste time explaining all this. I'm going to cover it in a question. So let's pick the first question for projectile motion. Yes, and before we continue, the same formulas that work in forward and upward, that is the horizontal and vertical motion, still works here. They work here. It's just that projectile motion will require you to know what the question will tell if you are to use the vertical or the horizontal. So that's why I said let's pick a question now. This is the first question A ball is projected vertically upwards from the top of a tower with a speed 20 meters per second. It takes 6 seconds to reach the ground. Calculate the height of the tower. Now, let's draw out this thing first. This whole thing that is happening, let's draw it out. Let's consider this as the tower. Then it goes, they said the ball is projected vertically upwards from the top. That means this is the top. The ball is projected vertically upwards from the top, but it's reached the ground. So that means something must have acted upon it. Then it goes like this to the ground. This is the ground. Then it goes like this to the ground, and it goes with a speed of 20 meters per second, and it takes 6 seconds to reach the ground. So now, because this speed, you have to be careful, because you know, as speed, projectile motion has, let me say, 3 different kinds of speed. It has the u, it has the ux, and it has the uy. Now you have to be able to tell from your question which speed is which. Now this speed here is uy, and why is it uy? They said the ball is projected vertically upwards. So that means this speed here is the speed with which it goes upward. So that means we can tell that this is uy. Assuming the question wasn't stated, probably assuming the question didn't state if it goes vertically upward or it goes vertically or horizontal. Assuming the question didn't state, then is the resultant u. But this one, it was clearly stated vertically upwards. So that means this is 20 uy, in this case is 20 meters per second. Then the t, the total time taken to reach the ground, is 6 seconds. And this is basically everything we have in this question. And you're told to calculate the height of the tower. Now, I would like us to calm down and follow from this point, because I'm going to break this motion down. Now, this ball is projected vertically upwards, isn't it? It goes and it reaches a maximum height. So that means if we can know this maximum height, if we can know the height with which it reached from this top of the tower to this maximum height, if we can calculate this, and we can also find a way of getting this height from this maximum height down to the foot, to the ground. If we can calculate, let's take this one as h1, and let's take everything here as h, big H. If we can calculate the maximum height from this top, if we can calculate the height from this top here to the ground, we can calculate the height from this top here to the top of the building, then we can easily get the height of the building. All we just need to do is the total height minus this little height that we've gotten up here, then it's going to give us the height of the building. Let's give the height of the building h2. So with this formula, we can, having known the total height, we can subtract this little height from it, then we get the height of the building. So this is the formula we are working with. But now the question is, how do we even get all these heights in the first place? And I know some of you might be like, this question cannot come out in exam. It actually came out in my own exam. Actually, this question that you're looking at came out. I can remember very clearly. It came out. So don't belittle any question. Now let's get the height from the top of the building to the maximum, to this maximum height, this point. Let's try and get this first. That means we are going to do calculation based on just this part of the motion. Let's draw it out on this other side. This part of the motion like this. This is the height, this is the top of the building. This is the top of the building. This is the maximum height. Maximum height. So we want to get this height here. Now, I now need you guys to bring your mind here, because the remaining, to fill out the remaining, because we basically have uy and only time. We need to fill out some other things to be able to get what we want to get. Now, if the ball is going from this point, they've already given us the initial velocity, so we know what the initial velocity. Now once it reaches this maximum height, usually if you throw something up, it's going to get to a point up there and it's going to rest before coming down. So at that point where it reaches the maximum height, it takes a rest. The rest might not be much, it might not be so obvious, but then it takes a rest. So we can then say, based on this, we can then say the uy is 20 meters per second. The vy, which is the final velocity, once it reaches this maximum height, then it reaches its final velocity, and we already know that it takes a rest. So we can then say v is 0 in this case. Now the fact that it's going upward means it is going against gravity, isn't it? So that means g in this case is negative 10 meters per second square, minus 10 meters per second square, because here the ball was going upwards as going against the velocity, and for something to be able to go against velocity, you must have a minimum of minus 10 meters per second square. Okay, now the question now is, how do we get h with everything we have here? How do we get h? I believe we still remember the formulas that we gave from the previous video, and if you haven't watched the previous video, please go back and watch it so you understand this part. We already know v to be 0, that is 0 square. We already know u to be 20 squared, 2 times, this is minus 10, g is minus 10, then h. So 0, this is 0, this is 400, and this is 20 minus 20 h. So 20 on 400, collecting like terms, it becomes minus 20 h equals to minus 400, minus cancels minus, h equals to 400 divided by 20, and that's 20. Height h1 in this case is 20. We've gotten h1. Now we need to get the total height. And getting the total height here would help us get the height of the building. We've already gotten h1 first. Now let's get this h, this capital H. And in order to get the capital H, let's come back to our projectile motion. Now that means we are working based on this other half of the projectile motion. So based on this other half of the projectile motion, let's try and see the parameters that we can get from this. Now remember that from this first half, this is the final velocity. Reaching here is the final velocity, which was 0, but because it now starts a new kind of motion, this now becomes the velocity with which it reached to get to the maximum height becomes the initial velocity for this next coming down to the ground. So that means we can take the initial velocity now, we can take this initial to be u y, we can take it to be 0 since it is coming from rest. We cannot tell v in this case, we can't. So since we can't tell v, we can't use it. Now we can tell g, isn't it? It is going under the influence of gravity. So this time around it is 10 meters per second, and this is basically everything that we have from, but it's not enough. If you check out the formulas, we need for the formula that doesn't have v, we need t. At least we need t, and a very good example is h equals to ut plus half gt square. We need t at least, so that means we need to find a way of getting t for this second half of the equation. But according to the question, we have 6 seconds for the total time. At least we already have the total time to be 6 seconds. That means if we can possibly find a way of getting t with this parameter, with only these two parameters that we have, we can't get t, and the reason is because it will still require a lot of parameters that we don't have here now. But the question has already provided us with the total time. That means if we go back to this first question, find a way of getting t from this first question, we can always use it to get the t for the remaining half, for this first half. Okay, now let's get t from this first half of the equation. We already still remember the parameters for the first half of the equation. We have uy to be 20 meters per second, we have v to be 0, we have what else again? I think we already got the height from that, from the previous one, which is 20, which was 20. We might not even use it. And we have g to be negative 10, isn't it? So let's get t. We can use v equals to u plus at. We can use plus gt, sorry, we can use this. V is 0, u is 20 plus minus 10 t. Then that's minus 20 equals to minus 10 t. Minus t then should be 2 seconds. So we've gotten t from the first half of the equation to be 2 seconds. Having known that, we can then say that since the total time is 6 seconds, we can then subtract this first half, we can subtract it, then we can therefore tell that the time for this second half of the equation is 4 seconds. So having known this, we can then find the h for the second half, and h, we can use the formula h equals to ut plus half gt square. U in this case is 0 times t is 4, half g, it is going under the influence of gravity, so g is 10 here, times t is 4, so 4 square. 0 plus half, this is 0, 0 times 4 is 0, half times 10 times 4 times 4 is 16, and 8 and 80 meters. So the total height here is 80 meters. Now, having known the total height to be 80 meters, remember that this 80 meters is the height from this top, maximum height, to the ground, which is, and remember that we said this maximum height is as a result of adding this small height here plus the height of the building. Height from the top of the building to maximum height, and from the maximum height to the foot of the building. So having known that, we can then get the height of the building. Since the total height is 80, the height from the top of the building to the maximum height is 20, according to what we did first. Then we can get the height of the building, which is 80 minus 20, 60 meters. So let's try one last question before we round everything up. The bullet is fired vertically upwards with a velocity of 120 meters per second at an angle 30 degrees to the horizontal from the top of a building 100 meters high. Calculate the maximum height. Okay, now this is another question. Let's draw out everything first. Let's draw it out. The bullet is fired vertically upward from the top of a building, so there's still a building here again. Let's assume this is a building. It's fired there's no vertical, it's fired upwards. That means, and the bullet reached the ground. So let's still follow the same projectile motion. Now it goes at an angle 30. That's if you draw out that stuff that we did from the beginning. 30 to the horizontal, 30 degrees to the horizontal. And okay, here we've been given the height of the building. The height of the building here, like this, is 100 meters. So now we're now told to calculate the maximum height of the bullet from the ground first. We're told to calculate the maximum height of the bullet from the ground. So we can go with the idea of what we did from the previous tutorial. We can go with the idea. Now it means if we can get the It means if we can get the parameters based on this first half of the equation, we can know the height for just this place alone, isn't it? Just like we did in that other one, we can know the height for just this part alone. Then we can sum it with the height of the building to know the maximum height to reach the ground, the maximum height of the bullet from the ground for the first question. So now we need to know how to get that first. Now, before we even do anything, we said the bullet is fired vertical. The bullet is fired upwards. Now they didn't tell whether it is vertically upwards or horizontally upwards. And remember, I said if it isn't stated, that u in this case is the resultant u. It is not ux, it is not uy, it is the resultant u. So now remember that in order for us to work this thing out, it is uy that we need. Remember. So let us first get uy. And what's the formula for getting uy? We did it earlier in this video, and the formula for getting uy, that's sine theta, which is opposite over hypotenuse, and uy equals to u sine theta. Already know the resultant u to be 120, then sine 30. 120 sine 30 is half times half, and that's 60 meters per second. Now we have gotten the uy, the vertical component of this velocity. Then we can use it to do the calculations that we want. Uy, we now know that uy in this case is 60 meters per second. And since it is going against the gravity, we know that the g is minus 10 meters per second square. What else again do we have from this? And we can tell the final velocity, isn't it? Since it's going to reach this maximum height and take a rest. So Vy equals to 0 meters per second. So having known this, let's now get the height. And remember that we can use this formula from the formula that we used in the previous. V square equals to u square plus 2gh to get the height. But I advise that we get the time first. Let's try and get time in order to make things simplified for ourselves. So let's try and get the t, and let's have all the parameters. That's using v equals to u plus gt. You can get the t. This is the y component. V is 0 here, u is 60 plus g is negative 10 here since it's going against gravity, and t, then this is minus 60 equals to minus 10t, then t equals to 60 over 10, which is t equals to 6. Okay, now we've gotten that this 6 seconds, it takes 6 seconds for it to reach this maximum height. Now let's now get the height. H equals to u plus v over 2t. We can use this, isn't it, since we've already gotten t. Then that's u is 60 plus 0 over 2 times t is 6 seconds. Then this is 3 times 6, that's 3 times 6 is 18, then 180 meters. So since it takes it 180 meters to reach the maximum height from the top of the building, that means the maximum height from the ground, we already know the height of the building, so the maximum height from the ground should be what? That of the building plus from the top of building to the maximum height. So this is 280 meters. So it takes it 280 meters to reach the maximum height from the ground. Now, what is the time taken to reach the maximum height? Okay, we've even somehow calculated this along the line. The time taken to reach the maximum height is 6 seconds because we've calculated it along the line. Now, the total time taken, now we need to know the total time taken to reach the ground. And I'm going to leave this part to you. If you've solved it, drop a comment below and tell me your answer, and let's see who gets it first. And for this last part, the distance covered from the foot of the building to the ground. Now this part also needs one to know this question 3. From the question 3 you can get the question 4, and I'm going to leave it to the first person that gets it. I'm going to leave it to the first person that gets it. So if you are following this tutorial, try and solve the total time taken based on the idea of the first question on projectile motion, and having got that, find the distance covered and the formula to use in getting the distance covered, which is same as range. That is, the distance covered is from the point of projection to the ground. That distance covered is the range of the projectile motion. It's called range R. It is the horizontal component of velocity times the total time taken. So this is the formula. If you've gotten it, please drop your answer in the comment below. Let's see who gets it first, and there's a prize for the person that gets it first. This wraps up the tutorial on projectile motion. It's actually a thick one, it's a tough one, yeah, I know. So if you've enjoyed this tutorial, please like, comment, share with your friends, and don't forget to subscribe.